Your phone's compass spins like it's haunted. I'll show you why it happens, prove it in under 10 seconds, and give you a step-by-step routine that fixes it or rules out the usual suspects. Put your phone face up on a wooden table or the floor, not a metal desk. Open a compass app so you can see the needle or heading. Watch it for a moment. Here's the core idea. Inside your phone is a tiny 3-axis magnetometer that senses Earth's magnetic field. Software combines that data with motion sensors to estimate direction. Earth's field is weak but steady. Nearby magnets and large pieces of steel aren't steady. They bend or overwhelm the field, and the compass obediently points to the strongest signal in view. That's the illusion. You think north moved. Actually, the environment changed. Introduce a controlled change and see if the compass follows. If it does, you've found the cause. Let's run the 10-second proof. Grab a small fridge magnet or remove a magnetic case or mount. Start with the magnet 20 to 30 centimeters away. Move it slowly in a circle around the phone. Don't touch the phone. Just trace a halo, then pull the magnet away. If the heading swings in sync and relaxes when you retreat, that's the cause. If nothing changed, that's useful too. We'll test for the second bucket. Big, ordinary metal objects that warp the field without acting like magnets. Slide the phone onto a metal desk, a filing cabinet, a stainless counter, or even against a car door. First, note the heading on wood, then repeat on metal. If the number shifts and stays shifted, that's a soft iron effect. The metal is redirecting Earth's field. Move back to wood, and the value should return toward baseline. If neither the magnet nor the metal test changed much, the likely issue is calibration drift. That's a calibration issue. Hold the phone at arm's length and trace a slow, wide figure 8 for 10 to 20 seconds. Keep it smooth. You're feeding the algorithm a clean sweep through different angles so it can solve for biases. Set it down again on wood and recheck. If the drift has shrunk, you've refreshed the internal calibration. If not, remove any magnetic cases or plates, restart the device, and repeat the figure 8 once more. One of those steps usually solves it. 3 buckets explain almost every wild compass. 1. Nearby magnets or magnetized hardware. 2. Ferrous structures that distort the field. 3. Sensor offsets that need recalibration. Don't guess, test. You just reproduced the effect and gained a control knob. Turn it and the needle obeys. Step 1. Baseline. On a non-metal surface, note the heading within plus or minus 5 degrees. Step 2. Magnet check. Circle a small magnet at 15 to 30 centimeters. Pass. It follows and returns when you pull away. Step 3. Metal check. Move the phone to a metal surface or near a car door. Pass. It shifts compared with baseline and stays shifted. Step 4. Calibration. Slow figure 8 for 10 to 20 seconds, then recheck. Step 5. Remove magnetic hardware, restart if needed, and repeat. Step 6. Validate outdoors away from cars and buildings. After this, you'll have either a fix or a clean description. A compass that settles and then snaps 90 degrees can be your device switching between 2 orientation solutions after it detects a different posture. A compass that rotates slowly while you stand still is often reacting to something moving around you. A rolling chair with steel legs, a tool drawer opening, a metal door swinging. A compass that disagrees with a map by a fixed angle is almost always magnetic declination, the offset between magnetic and true north. Check a declination map for your city. A modern dashboard hides speakers, vent magnets, steel supports, and sometimes wireless charging coils. Place a phone near the cluster, and you're bathing the sensor in local fields. If navigation jitters in a car, repeat the magnet test in the cabin. Move a small magnet around the dash and watch the compass respond. Then move the phone to a cup holder or a cloth pad away from the dash and watch it calm down. Fix it by increasing distance or relocating the mount a few centimeters and retest. Calibrating next to a closed laptop, a large speaker, or a metal chair can imprint a bias during the very motion meant to remove it. Do the figure 8 slowly. Running tests in an elevator or subway gives you changing steel geometry the whole time. Save the checks for open space. If your case has a hidden steel plate, it can drag the heading even on wood. Take the case off to test. Step into an open area, away from buildings and cars. Hold the phone flat and face a distant landmark. Note the heading. Walk 10 steps to the side, keeping the landmark in view, and check again. In clean surroundings, the number should stay within a few degrees. Now use a pocket with a magnetic clasp or put the magnetic case back on and repeat. If it now shifts or jitters, you've isolated the influence to hardware, not the sky. Keep magnets and strong speakers 15 to 30 centimeters away during calibration. Don't store the phone pressed to a magnetic mount when you don't need to. Refresh calibration after a long trip, a system update, or anytime the compass feels sticky. When navigating in a car, favor a plastic mount or a soft pad away from vents and speaker grills. If you work on steel benches, do important checks away from them. And remember, a steady, repeatable mismatch between magnetic and true north is usually declination or a setting, not sensor failure. Measure. Don't mythologize. You turned the magnet knob and the needle moved. You turned the metal surface knob and it shifted again. You turned the calibration knob and the drift shrank. Each knob is a falsifiable test. If the reading doesn't follow, you learned where not to look. If it does, you found a cause you can control. If your compass still behaves strangely, collect a clean report. Surface, accessories, distance from metal, magnet sweep result, and what happened after a figure 8. Note whether you were indoors or outside and whether GPS was on. Some apps blend both. With those details, we can tackle harder cases. Things like electric currents, power tools, or unusual building geometry. To finish, run the 10-second proof again. Magnet 20 to 30 centimeters away, slow circle, then pull back. Watch the heading chase your hand and relax when you retreat. That's your demonstration that the impossible spin has a simple cause. Comment where yours spun, what object was closest, and which step fixed it. Next time, streetlights that seem to flicker on command, and the quick remote IR check that settles it. Keep your curiosity high, your tests simple, and your conclusions tied to things you can rerun tomorrow. One more note before you go. The gyroscope and accelerometer do not point north. They only track motion and tilt. Heading comes from the magnetometer, and the app needs permission to access it. If your readings never change, check app permissions, then try a different compass app as a control. Also confirm you haven't forced true north mode without a data connection. Some apps need a moment to fetch your local declination. When in doubt, switch between magnetic and true north and see if the offset matches your city's published value.